Hello and welcome back to Math with Mrs. Becker. Today we are going to be creating what are called lines of best fit using technology. So before we get started, please make sure that you have your phone or an iPad or a computer, something by you where you can access Desmos.com. All right, we are looking at college algebra, finishing up chapter 1, section 7. You can use what is called the regression feature of a graphing calculator, and for us we are going to use Desmos.com, but it will help you to find a linear model for a set of data. Now yesterday, remember, we graphed scatter plots by hand. Then what you did is you created what was called a line of fit. You looked and drew a line where you felt it fit the data. You had the goal of having the same amount of points on either side of the line. Then you picked 2 points from your line and you found the equation, okay? There is something called a line of best fit, and your calculator can actually give us the equation for that. It would be the best line that would fit through that data, okay? As we go through this process, you will notice that the program also gives you an input for what is known as an R value. So as we go ahead on Desmos on the bottom, you will see R equals. What that R value is, it is the correlation. Remember yesterday we talked about correlation. It is the correlation coefficient. Correlation, if it's positive, it means that as you go to the right, your Y values tend to get larger. If it's negative, as you go to the right, your Y values tend to get smaller. If there's no correlation, it means that there really isn't a relationship between the two variables. Now what R does, your R value is going to be in between -1 and 1. The closer the value is to 1, and its absolute value, so meaning closer to a -1 or closer to 1, the better the points can be described as a line. So here, notice here's our points from the scatter plot. Let's kind of have some visuals for you. This is our R value. It's our correlation coefficient. This is pretty darn close to 1. What that means is that when you have that line of best fit, those points are pretty tight. They're close to that line, okay? The points themselves almost form a line. Now here, this is positive because my slope is positive. This is a negative correlation. That's why my R value is negative. You want this to be as close to -1. If it's close to -1, that means that your lines are really tight together, almost forming a line. This is still pretty close to a -1, but notice these points are more spread out than these, and I can tell that by the number. This number is closer to a 1. That's why the points are closer to the line. This number is not as close to 1, so the points are a little bit more spread out. Now check this out. This is like a no correlation situation. If you went in and tried to make a line, the calculator is going to try to make a line for you, but notice this is telling you this is nowhere near close to 1. That means that this really doesn't have a linear relationship. So what that correlation coefficient is measuring, it is measuring the strength of the linear relationship. How strong of a linear connection is this? How good is it that we form a line? Is that line going to be something that is accurate and we can actually make predictions? Okay, so without further ado, we're going to go ahead and do this. So the first example, because I know that this can be kind of time consuming, you are going to use a graphing utility. I'm going to go ahead and show you on Desmos. Okay, so I went on to Desmos.com. When you go to add an equation, okay, so this is what it normally looks like, okay? Up where you hit the plus sign, that's where you get other options. So in order to put a table, it's plus sign and you put a table. When you enter a table, what happens is they will give you a table. It's X1, Y1. This green shows you that they are doing a scatter plot in green. So what I did just ahead of time, I went ahead, did the table. I took every ordered pair. So you'll notice 10.0, 10.0 and 70.5. Here is 8.5, 67.0, 10.0, 71. So I just went ahead earlier and put the table, put the ordered pairs into the table. Now when I look, I'm like, hey, I can't even see anything. Well, you have to look at the window. If I have my normal window, it goes -4 to 4 and -6 to 6. If I look at these points, yeah, none of those points fall into that range. So remember, very often you're going to have to be able to set your window. So you hit that little tool key. My X values, if I look at the first value, the smallest value that I really have here is an 8. The largest value that I have is 13. So I'm going to go ahead. I want to make sure I see everything. I'm going to go like 5 to 15. Okay, so I went a little bit to the left and a little bit to the right to make sure I see all the points. Now my Y values, the smallest value that I see, I have like a 67. The largest value, I have like a 76. So my Y's, I'm going to go like, let's go 60 to 80. Now when I do the, hey, there is my scatter plot. And I knew that the points for this graph was going to be green because if you look at the table, that's what that green means. So here is a scatter plot. I can go ahead and look at that and say, okay, that is a positive correlation. If we want to find the correlation coefficient, what we need to do is have Desmos.com create the best line. It's going to create, it's the line of best fit because it's using technology to make the best line. What you do is go ahead, hit the plus sign again. We want an expression. We want to know the equation for the line of best fit. Now notice your ordered pairs. It's X sub 1, Y sub 1. So when I tell the calculator or Desmos what I want to do, I want Y to get the sub 1, you just hit a 1. So Y sub 1. It's calculating a regression, okay? Meaning that it's putting in that line of fit. So it's an approximate symbol. We can't say equals because it's not going to go through every single ordered pair. So we want Y sub 1 equals, now I want a linear line, so M, X, but I need the X1 because I wanted to use the X's from my ordered pair, plus B, Y equals MX plus B. The sub 1s are to get the values from my table. Okay, now this is so cool, you guys. So that is the best line. That's your line of best fit. The calculator found it for us. Notice here is our R value. Our R value is 0.98. That is so close to 1. That's why these points are really, really close to the line. So let's go ahead and see what the equation or see what the questions say. Determine the line of best fit using the calculator's regression feature. So our line is Y equals MX plus B. Notice the calculator tells us M and the calculator tells us B. So I just fill that in. So the equation is Y equals M is 1.80048. So I'm going to go 1.8, okay? Because after that it's a 0, 0. M, X plus B. B is 52 point, I'm just going to put it all, 3882. That is the line of best fit. That's the line that they just graphed here. That's what question number 1. Determine the line of best fit. You fill in your M, you fill in B. Again, Desmos gives that to you. There's M and there's B. What is the correlation coefficient? What is the R value? R equals 0.9846. What does that imply about the data? This is close to 1. So that means there is a strong linear relationship. The closer this value is to 1, the stronger this is. This is really close to 1, so it's a very strong relationship. Use the regression equation, there's our equation, to predict the height in inches for a man with shoe size 14. Okay, my bad, I didn't even read the problem to you. The following ordered pairs represents the shoe size. So the X value is the shoe size, and it tells you the height in inches of 15 men. So you know their shoe size, how tall they are. They want to see, does that really mean if you have bigger feet, are you going to be taller? So what they want us to do is go ahead and predict the height. If the shoe size is 14.0, remember the shoe size is the X. So it's Y equals 1.8, X is 14.0 plus 52.3882. So I'd have 1.8 times 14.0 plus 52.3882. The prediction would be that that man would be approximately 77.588. So I'm going to go 0.59 inches. Again, it is a prediction. So feel free to round. So we're saying that they would be about 70, close to 78 inches. And if you look, that would be the biggest shoe size that we had here. And that would be the tallest man. Kind of cool. Graph the scatter plot and the line of best fit in the same window. When you take your test for this chapter, this is one of the test questions. I'm not making you draw it. What you have to do is get this onto your screen, raise your hand, I come and check off that yes, you do have the line of best fit. It is going through your scatter plot. Okay, so there's one just to show you how it works. Now let's do one together. Okay, so let's go ahead and X that out, and I don't want that anymore. X that out. It says use a graphing utility. For our sanity, we're using Desmos. Okay, some of the other ones are not so friendly. Use a graphing utility to find a linear regression model for the given scenario. This is the average monthly cable television bills. So here are the bills in dollars from the year 1990 to 2004. Use a graphing utility to create a scatter plot of the data. T equals 0 response to 1990. So what that means is that where it's 1990, that's your 0. Your Y would be 16.78. 1991, that would be 1 and $18.10. This would be 2 and 1908. Okay, so make sure that we do this. We're not putting in 1990, 1991. T equals 0. That is 1990. So after that, 1991, it's a 1 because it's 1 year later. 1992, it's a 2. So let's go ahead and put the table in. Okay, so if I go add, I want to add a table. Notice it goes X1, Y1. So I go ahead, my first ordered pair is 0. Tap the Y, it's 16.78. And you just got to be really careful as you're entering this, because if you just saw mine, my decimal did not go in there. So I go ahead and I put a little check mark when I have each one done, so I don't accidentally miss a point. Now I have 1991, so that's a 1. Go over $18.10. Go to the next order pair. 2, I hope you're doing this with me. Otherwise, this is going to be really boring to watch me enter points in Desmos. Okay, please make sure that you are practicing this. Like I said, you'll have to be able to do this when you get to the test. 3 and 19.39. Check. 4, and the cable bill went up to $21.62. Check. 1995, so I put a 5 in the X value, 23.07. Got that one. Next one is 6. Then it's 24.41. Check. 1997. Hey guys, we're getting there. 26.48. I hope you're having a great day today and enjoying learning something really cool on Desmos.com. This is our last section of Chapter 1. Just some small talk as we're doing this. We're getting close to our test. This is the last section. We'll have a worksheet to practice this technology. We'll review for the test, and then we will take the test and move on. So when you get to 2000, that's 10 years after 1990. So 2000, you would have a 10 for your X value. Notice these bills. I don't know about you, but as I'm entering the numbers, I notice that the bills go up a little bit more every year. 2001 is 11 years after 1990. I have 32.87. Go ahead and cross that off. Now I have 12, and it's 34.71. Check that off. 13 years after 1990, the bill is $36.59. Got that. 2004, that's 14 years. Hey, that's the last one. And it's 38.23. Check. All right, so I'm done with my table. Let's go ahead and look at it. I hit home. Yeah, I don't see anything. Well, lots of times you don't see anything unless you set your window. My X values are 0 to 14. So let's go ahead and go 0 to, let's go 15. Now my Y values. The smallest Y value is 16, the biggest is 38, so I'm just gonna go, let's go 0 to 40. There is my scatter plot, awesome. Okay, so we have that. Use a graphing utility, create a scatter plot. Check. Use the regression feature, so that's where it's Y sub 1 is approximately, use that little regression, it looks like an approximate symbol, M X sub 1 plus B, because what we're doing is Y equals MX plus B, but we're doing the regression equation. So to do that, where it's a plus sign, we want an expression. It's Y, to get the little sub 1, you just hit 1. Now I need the approximate symbol, M for the slope, X, I need the 1 to get the ordered pairs. So I go ahead, mx sub 1 plus, I need to know what b is so I can find the equation. So I go ahead, there's all the information that we need. It calculates it and it visually shows us where the best line would be for that scatter plot. Identify the correlation coefficient. That's the R value. Our R value, check this out, 0.9954. That's even closer than our other example. Graph the model in the same viewing window as your scatter plot. What that means is you need a line in the same screen. So on your test, you would raise your hand. I would look and say, okay, do you have a scatter plot, any line going through it? Check it off and you get your points. Okay, so we did that. Is this a good fit for the model? Heck yeah, it is. Absolutely. Why? Because it has a very strong linear relationship. If this is close to 1, as close as you can get to 1, that's how you know if this is a good fit. If this were to be like 0.1, yeah, not so much. But the closer this value is to 1, the better fit it is for the model. Now, use your model from B. Okay, so use the regression to find a linear model. So that's an equation. So y equals, here's my m and b value. Again, they're right here. Y equals m. M is 1.55182. I'm just going to go ahead and write the whole thing. X plus b. B is 15.6993. That is the equation for that line. So this is your, for part B, they called it your linear model. Linear model means your equation. So use your model from B to predict the average monthly cable bills for the years 2005 to 2010. Okay, so 2005, X would equal 15, right? So if I go ahead and I put 15 in there. So 1.55182 times 15 plus 15.6993. The ordered pair, I'd have 15 and the cable bill would have been $38 and it's money, so 98 cents. Okay, now if it is 2010, that is another 5 years, so X would be 20 because it's 20 years after 1990. So if I put in a 20 in here, 1.55182 times 20 plus 15.6993, I have 46.735, so it'd be $46.74. So we have those. Use your monthly, or use your model from B to predict the average monthly cable bills for the year. So if you're doing the average, remember to find the average. You add the two together and then divide by how many numbers you're looking at. Okay, so we want to know the average between these two. So if I go ahead and add them, 38.98 plus 46.74. So 85.72, we are looking at 2 different years. Okay, we're looking at 2 different data points. So if I divide by 2, the average bill would be 42.86. So remember, like if you want to find the class average, you would add up everybody's scores and divide by how many you have. Here we're adding up the 2 bills, dividing by, we're looking at 2 different years. So in between there, the average monthly cable bill would be $42.86. That is all we have for graphing lines of best fit on technology. Tomorrow we will look at a worksheet where you get to practice this a little bit more. Hope you had a great day. Talk to you soon.